Okay, so I want everyone here to understand what this sentence means by the end of this talk. The theory of everything is embodied by abstract replicators called Femes. Who's all from a physics background? Any hands? Physics? Biology? I don't know if any biology. Nice. Like computer science, kind of IT stuff. Yeah, nice. And does anyone want to? What else do we have? A lot of math.
Psychology.
Okay, lovely, perfect. The reason I ask is because this intersects quite a few disciplines, namely physics, biology, kind of maths, computation. The whole point of what I'm trying to do is explain that my conjecture that there are not only three abstract replicators in reality. This is what we currently understand in contemporary theory. Genes, memes, and themes exist. My work suggests that themes exist. It's always nice to get like a personal background on why someone does what they do. I feel like it helps me learn about scientists, learn who they are as well as their science. So I came up with this about 3 years ago. I just thought one day it makes absolutely no sense that we start with the universe at the Big Bang. We have a load of assumptions. Here are the assumptions we have, and in physics there's very, very minimal effort to explain beyond that, to explain why would the universe have the state that it does. They're just kind of bundled questions and not taken seriously in contemporary physics. But yeah, I said, this kind of annoys me, and then I went to my bed, it was 12 o'clock, and I started thinking, what happens, what could possibly exist other than our universe? And then the thinking goes on, and it's just information systems. What happens in any information system is evolution, knowledge propagates. That's what happens. So the overwhelming likelihood is that that is what happened in the information system that existed previous to the Big Bang. Evolution happened, and what does evolution always result in? At these levels of abstraction, we can see it as replicators. The conjecture is that similarly, before the Big Bang existed, there was an evolutionary space that resulted in these replicators called Femes that interacted to cause the form and dynamics of our universe. In order to understand this at the level that I'm trying to explain it, we need to consider what the theory of everything is. Is anyone familiar with the Wolfram Physics project? So we're all here, we're all excited to see Wolfram later. In that work, there is a fundamental update rule. So what happens is that we have reality, and in the Wolfram Physics project, what happens is that the reality, the hypergraph, is updated by some structure, by some computational structure, interacts with the hypergraph, and it results in the dynamics of the hypergraph. This is a general way that the Wolfram paradigm fits into this map, but this could also apply to many other ways that the theory of everything is framed. But the idea is that, and the key find from the Wolfram Physics project, and what was so groundbreaking about it in 2019, is that they found out that reality can be parsed, or not reality, a large group of hypergraphs and their update rows can be parsed at a numerically reducible level of abstraction into quantum mechanics and general relativity. But the update row is different. It is not the form of quantum mechanics and general relativity. As Wolfram says, I think it was a TED talk, he kind of goes back on it a little bit, but what he says is that what he wants to do is find the fundamental update row. The idea, and it's agreed with numerous different paradigms, especially because modern physics is essentially all discrete, is that there's a fundamental theory of everything. And it's parsed into general relativity and quantum mechanics. That's the view we have. That's what theory of everything is. Problem with the theory of everything is that it's highly specific. So there's a bunch of different forms that it could have. In string theory, there are 10 to the 300 possible Calabi-Yau manifolds. It's essentially a problem in every theory of physics we have. You need to be extremely specific about its form. It's therefore arbitrary in some sense. And that is referred to as the fine-tuning problem. So why the theory of everything has a highly specific arbitrary form is the fine-tuning problem. The first apparent solution we've discussed is essentially the attitude of contemporary physics, which is the null hypothesis. It essentially states that It's not the job of physics to find out why the theory of everything has the form that it does, it just does. That's not very satisfying, obviously. In that, if you analyze these explanations by something called Occam's razor, you need to look at it. Occam's razor says that the explanation with the fewest assumptions is most likely to be correct. In the null hypothesis, we have the theory of everything just exists. That's a given, number one. Two, the initial conditions specified by inflationary models. That's the null hypothesis. We also have an anthropic. The anthropic principle essentially states that we exist in this universe, and this universe has this form because it's only possible for us to exist in a universe with this form. If the laws of physics were different, they wouldn't result in humans, they wouldn't facilitate evolution of complex life. Therefore, many universes may exist, our universe exists, therefore we exist in this one. However, that doesn't actually solve the fine-tuning problem. It still exists in a similar significant way because you require the assumption that a multiverse exists. People seem to not think about this, it's a multiverse, but in order to generate a specific theory of everything, even if this multiverse is infinite, you still need to place constraints on its form in order for it to result in a specific theory of everything. No infinite structure can be bijected with all possible infinite structures, therefore you can't have an infinite multiverse that automatically generates a specific finite structure. It doesn't make sense. Yes.
You might want to give a more kind of conceptual overview for like a couple sentences before you describe what the properties are mathematically so that it can reach a more diverse audience.
Yes. I'm not sure how to do that in that context.
What's the big idea? What's the big idea?
The theory of everything has a really specific form. We need to explain why it has its form.
Mm-hmm.
These explanations are not satisfactory. My work proposes a third explanation, evolution. In this system, you don't require all these assumptions. You only require one assumption, two assumptions. First being that information exists and interaction is Turing complete. Or universal. So these two assumptions are so much lighter. Therefore, by Occam's razor, if this evolutionary explanation works, we would favor this evolutionary theory. In order to explain this a bit more, what we need to do is go through. Sorry. Yeah.
So could you explain a bit the second assumption? So we by interaction is universal.
Yeah. So we need to explain this. So that's the general overview of what I'm doing. That's everything I'm doing. In order to, so that's the intuition that I had a number of years ago. Evolution works for solving the fine-tuning problem. Then over the next number of years, what I've done is formalized it according to constructor theory, which allows for predictions. So what we're going to do now is do a background in constructor theory. And then predictions. Okay, so the way that I will explain this is just using examples. So constructor theory was invented by Marletto and Deutsch. Deutsch came up with one of the first quantum algorithms in 1995. 2011, he wrote a few papers on constructor theory with Chiara Marletto. What it does is formalize what information is and what happens in general information systems. So it's considered a meta theory of physics because it's not necessarily about our universe. What it is this is what happens in general information systems, and then allows explanations of reality according to that, with the observation that our reality is a subset of that larger space of all information systems and their general behavior. To explain that fully, we'll need to define terms, so we make our foundations quite solid. What is information? It has counterfactual potential. A function can interact. This symbol notes, or this symbol means interaction. A function interacts with this square. The function asks, is this square black? And outputs a black equals true, white equals false. The reason that these both constitute information is because if you change the function, you'll get a different output. If you change the input, you'll get a different output. Counterfactual potential is the potential to be different. It is what defines information. Turing completeness, what? So what Turing completeness means is that it's a property of operators. So it's actually a really simple idea. What it means is that you can take this side and this side, and you can use the operators to transform anything, any set of boxes on this side to any set of boxes on that side by composing these gates in different orders. That's a property of an AND gate or an XOR gate. It's demonstrated by the fact that you can compose an AND gate to form an XOR gate. What happens is that you take this, rearrange it in these ways, it produces this different output. Therefore, the concept of Turing completeness is that it's a property of operators which allows any input from any output.
Sorry, before you carry on with the definition of information, basically then you define it like with like using the concept of counterfactual, if I may.
Yeah.
And so, did you get from which other, if there was one, did you get inspiration with it? Because, for example, I'm interested in Julia Perl's concept of causality related to counterfactual stuff.
Yeah, Chiara Marletto, she wrote an excellent book called The Science of Can and Can't. And that's what it's about. And then what that book moves on to is knowledge. So before we explain the concept of knowledge, we need to explain what it means for something to be abstract. So we've got the theory of everything done. Abstract is next. Does anyone know what it is? Show of hands who's heard of the game of life? Okay, and keep them up if you know what a glider is. Okay, so apologies if this is unfamiliar. If I had Wi-Fi, I'd show you properly. But what happens is you have this grid. Every single cell in this grid interacts with this function and updates. So this grid is no longer black here. The reason it's no longer black is because the number of neighbors determine its future state. So you say all these grid cells, update all of them, then you get this shape, then you get this shape, then you get this shape, then you get this shape. The function game of life is a function that defines how the update happens. The glider is this object and these objects. It is an abstract property. What defines abstraction is the fact that you can determine the future state by less computationally expensive means, by less computationally expensive update. Namely, the glider moves square root 2 grid cells every 4 iterations. It's less computationally expensive than the fundamental update. Therefore, the glider is an abstract object with abstract properties.
So if I understand correctly, the game of life is a series of like tessera or like squares and some rules as to how they evolve in relation to the colors around them.
Yeah.
And a glider is a structure that evolves in a particular way.
Yes. Yes. The way it evolves is that it does this update and recreates itself square root 2 grid cells. Yeah. And that's what defines numerically reducible and tractable. These words are just ways to describe that. You can do things by less computationally expensive means, and it's involved. Abstraction is an important concept in modern physics. Oh, sorry. Yeah.
Is that diagram a description of an update rule, or is it a behaviour that is explained by an update rule?
Yeah.
The question is an update rule a state of affairs, or is it a kind of high level? You know what I mean?
Yeah, good question. That diagram isn't good enough to explain it. The update rule is like it's the function it takes in. So a number of neighbors or a number of black squares around some object. Okay, function takes that in and says if it's 1, 2, or 5, just f5, like if statements essentially, f5, it's still a square. So it's an update on a single square. So there's 6 by 6, so 36 squares. Code. What is happening in this interaction is all 36 of these squares are getting plugged through this, and all 36 of them are having an output state. Then you have the abstract layer. That's everyone get it? The glider is also knowledge. So all that they care about in constructor theory is essentially knowledge. There's a YouTube video where Deutsch says that everything that happens in the universe can be explained by the concept of knowledge. But it's quite paradoxical because in like traditional science, it's not really a big feature. But what it is any structure that tends to remain in an environment once it is instantiated. The glider is knowledge because it creates itself in the future. That's what knowledge is. Properties of knowledge, it is hard to vary and it's hard to come by, meaning that it's a subset of possible structures constitute knowledge. The majority of 3 by 3 structures on an empty grid interacting with the function game of life will fail to propagate. We've already seen the glider, it's parochial and fallible. There is an infinite set of environments across which any structure that can exist will not propagate. That's what parochial and fallible mean. Okay, so yeah. So constructors, this is the idea, this is the namesake of constructor theory. A constructor embodies knowledge. It allows it to exist in the exact same way after some interaction. Here, platinum causes this interaction, but it has the exact same form afterwards. The function game of life is not knowledge, in that, if you just isolate it here, the rows themselves do not propagate through time. It needs interaction with computer memory or it is stored in order to propagate through time. So, function game of life is actually knowledge whenever you embed it in our reality, which I'll explain shortly. Yeah, what's your
question?
Yeah, I think the knowledge thing. Can you give that one more go if that's all right?
Yeah.
Before it gets put in the game of life function.
Yeah. I'm just trying to think of the best way to explain it.
Because parochial and fallible is like there's a lot going on there.
It's a little bit what's right?
There's a lot going on with the words parochial and fallible.
Yeah, no, there definitely is. So there are an infinite set of possible computational structures. Some finite structure, imagine the glider object, some finite structure will propagate on an infinite number of other structures and will fail to propagate on an infinite number also. So, just remember diagrams. Yeah, alright, sorry, this explains it. So, you have an eater here. An eater, this is called an eater, it's another object in the game of life. When the glider interacts with the eater, it is destroyed. So that means that the glider is fallible. Fallible meaning it can fail to propagate some interaction. Similarly, if you vary the update rows, so the game of life rows are varied, the glider also fails to propagate. So anything that constitutes knowledge is only parochially defined. It only constitutes knowledge in some specific environment. That's what the word parochial means. And then problems are inevitable and soluble is an idea that Deutsch talks about a lot, but it's essentially that problems are inevitable. Any structure will definitely, in its future course, encounter another structure that will destroy it, and all problems are soluble. Any structure that will destroy you yourself is similarly a finite information structure, therefore you can evolve knowledge to overcome that and survive the interaction.
I asked you this when you gave the talk in Amsterdam, but is there any embedded concept of reasoning or like I guess like a background for knowledge, or as long as something is true it will constitute knowledge? Like we spoke about the Gettier cases, even a wrong clock, even a stop clock is right 2 times.
Yeah, so it's right 2 times a day because 2 times a day it's in the environment. It's so the majority of environments that the clock encounters throughout the day, so as we said as well, knowledge is hard to come by and hard to vary. So the form of the clock constitutes knowledge for 2 minutes a day if it's broken. And then the vast majority of possible times it does not constitute knowledge. But it's kind of confused because it doesn't cause itself to propagate. It's potentially a bad answer on my behalf. But yeah, whenever you talk about reasoning, it's just all about, we go into reasoning whenever we go into mimetic evolution, so we'll go into that shortly, like how this relates to kind of psychology and human psyche. So we have this viewpoint, information, subset of information are constructors, and then we now introduce replicators. So that's abstract done. Now we move on to replicators and what they are. Replicators are constructors that can cause a copy of themselves in their environment. So they interact with their environment to cause a copy of themselves. They're therefore a subset of constructors. They are extremely important for explaining the form of reality. That is because of evolution. So whenever you have a replicator, what happens is that you have repeated cycles of imperfect copying and selection of information. What happens is you have one replicator, causes replicants of itself. If the information copying is imperfect, you get imperfections and mutations. Selection by the interactions with the environment, then replication again. Repeated cycles allow significant knowledge to be built up and embodied on the replicators. Here is, okay, so every single abstract structure we can see has causal explanation by interaction with replicators. In school, we are only taught about the replicators of genes. These exist in butterflies. They interact to create this phenotype. There is a genome, it has a bunch of genes in it. During sexual reproduction, the genome is spliced. The genes propagate on many variant genomes. This is selected by how it interacts with the environment and the phenotype that it creates. Phenotype is any structure that results from causal interaction with a replicator. What happens here is that the offspring, the environment selects for dark colors, therefore the dark colors propagate. That's genetic evolution. What's really interesting and absolutely blew my mind over the last couple of years, because of how relevant it is in every second of your life, is mimetics. If I give a thumbs up, everyone in this room can see the thumbs up. You've all created an abstract structure in your own brain, a representation of that object. So neural processing is a substrate that can create abstract objects. Those abstract objects can create copies of themselves whenever you guys observe this. So you've created that, and then if you choose to enact it, you go out into the world and enact this, and everyone starts enacting this, then in our brains, in our neural processing, there's a bunch of objects representing this object. That's what mimetics is. It's the fact that all of our actions, even though we think we're really independent in that, are actually, we're a bit more slaves to replicators than we would like to be. Susan Blackmore came up with the term teams. So in 1937, we first instantiated information in digital bits. Digital processing systems can embody objects. Those objects can go through the process of copying, varying, and selection. So your phone is the phenotype of the abstract information that exists in silicon processing systems within it. Properties of all evolutionary replicators. They are selfish. That's why Dawkins named his book The Selfish Gene. That's also the same book that he introduced the name mimetics, coming from the term mime, which means to imitate. They are error correcting. So Claude Shannon was the father of information theory. He came up with the fact that you could error correct in a noisy channel to an arbitrary degree of accuracy. Hammond later created error correcting codes in 1954. So Hammond codes are an ultra-efficient way of error correcting. It's about attaching redundant bits to some message so that whenever the receiver gets a message, they can correct for the original form of that message. Error correcting codes are also observed in memetics and genetics. Memetics, the idea of creating things in your head. If I say, I'm talking about my friend, I say he is a doctor who is respected for his work. I really want you to know the gender of my friend, so that's why there are two references to it. It's a degenerate reference to the meme, essentially, so that the message can still be transmitted whenever there are errors. So if you miss the first T or the second T, you still get the message, all the information. Can I go on to the next page?
Yeah, of course. I just tried to find out. Oh yeah,
Yeah, so this is the perspective that we now have on reality. 4 billion years ago, genes existed. They created all these abstract objects. 600 million years ago, neuroprocessing evolved. Sometime after that, abstract objects could be instantiated in that neuroprocessing. They created their phenotype, which resulted in swords, yin and yang, and like tractors and that. 1937, Femes came along. They interact to make this computer and Facebook. That's our perspective on reality, and now we have done replicators. So now we have genes, memes, teams. This means fundamental things. My work proposes that there's a fourth abstract replicator in reality. It has been called Feme.
Can you take one moment to do it? Oh, it's the audio score. Yeah. Oh, okay. That's right. Yeah, that was all this. Yeah.
Perfect.
Feel free to move the smile window. Bring on to stop the. Yeah.
Alright, so this is the perspective my work proposes. Yeah, we've already seen it essentially. So the universe is the phenotype of Femes. Femes interact with their environment, create a universe that has abstract, numerically reducible form that's consistent with quantum mechanics and general relativity. And it evolves through time, the phenotype, to create stars and planets and that. If this was true, what would the consequences be? I have now 5 predictions. So now we're at the predictions. About things. Yeah. Okay, 5 predictions. First prediction, they embody error correcting codes. So they embody Hammond codes, suggesting selection for error correction and efficiency. This is a nice idea. One time I was sitting listening to a podcast, I was just sitting down, and it was Jim Gates, and he says all this stuff about his work. So what it turns out is that Jim Gates found these type doubly even self-dual linear binary error correcting block codes. They're a type of Hammond code. He found them in fundamental supersymmetry equations. This makes him believe that there was some kind of form of evolution acting on the mathematical laws of physics of our universe. Quite nicely here. So, and also this is more general than a lot of the other supersymmetry work, so it's not as likely to be disproven in some sense. You can look it up. Other people know more about it than I do. They embody a program for self-replication. This is actually quite nice because it lends itself to experimental validation. So von Neumann predicted the existence of DNA in organisms because they would need to have some structure inside them that was able to create a program. It has a program for its own self-assembly. Similarly, if themes exist in reality, they can interact with reality to cause another copy of themselves. That information system is different, therefore it can interact in a different manner, and lends itself to the experiment. Themes are fallible. As stated previously, all knowledge is fallible. It only propagates in some subset of all possible information systems. And that's actually quite nice, because I personally find heat death quite depressing. The fact that, or the potential that themes exist, and that's the reason the universe has its form and dynamics. That would mean that themes are knowledge, all knowledge is fallible, therefore heat death isn't necessarily the consequence. They're information efficient. Evolution selects for information efficiency. Selection for Hammond codes also suggests selection for efficiency. Therefore, interpretations like the many words interpretation are less likely to be correct. Fine-tuning results from selection of knowledge. So that's kind of the last one. It's the most open-ended prediction. But the whole idea and what we're trying to solve is that the universe is finely tuned. So therefore, evolution has selected our universe to be capable of facilitating complex evolutionary pathways. Yeah.
What do you envision the evolutionary pressures to be?
Potentially, nice. I would like to write another paper about. So these are the 4 abstract replicators. What actually happens, and it's well documented work, like Susan Blackmore's like brain hypothesis, is all about how memes have selected on genes in order for genes to create brains that are more capable of facilitating mimetic evolution. Therefore, memes have resulted in the form of genetics. This is the most conjectural part, but it is where my current exploration is that themes could similarly have been selected on by abstract replicators that existed in this space previous to the Big Bang that resulted in their form. The previous space selected for a form that resulted in a universe that could facilitate complex evolution of life. Yes?
I have one question, but what you said now, I have another.
Yes.
The question to what you said is, so then you would say that the evolution of themes would be purposeful? Like it would have a purpose?
So, nice question. What does purpose mean?
It means that it's not stochastic. I mean, in the sense that if you have genes, depending on the selective force, they're just happening and happening and happening. And that seems to lead somewhere, but it really doesn't.
Yes.
If you say that themes could be guided to the generation of genes and so to means, that would mean that in the, I think I didn't really quite understand the theory, but that in the primal universe, there's something that is selected, that's a selection for genes and means.
Yeah, so purpose is difficult because you feel like you have some altruistic, really important purpose in the universe, and then you read the selfish gene and you think every action that I've ever taken has been completely motivated by something that's different from me and is so beyond impersonal. It's like a nucleotide basis. That's what motivates my existence and belief. It's mental. But the point is that purpose is similarly parochial and fallible. There's no overarching purpose in the universe. Like that's what mathematicians thought back in the day. Said maths is a language that transcends linguistic barriers. Therefore, it must be the universal, really important language. That's why Euclid's fourth axiom was really awkward, because it wasn't disproven until the 1700s. The point is that even maths is fallible. It's not a universal, extremely important language. It is finite and limited. That's proven by Gödel's incompleteness theorem. Similarly, purpose can only ever be parochially defined, and maybe the universe has a purpose to create life, but that purpose will overwhelmingly likely, I don't know, purpose is a strange word. It's created to do something, but yeah. One more question.
This is, maybe it's in the part of information theory that I didn't really quite understand. But when we talk about genes or memes, the word genes or memes, you refer to like an abstraction of something that it has a certain character. Like you have nucleotides that can